Mercury is the planet of paradoxes and extremes. Let's talk about that planet, what we know so far about its size, rotation, geology, surface. From recent studies, let's explore why this planet is so hard to study and what future may be for that planet. For a long time people knew that this planet is very small and is located the closest to the Sun. Already as far as in Sumerian times, people knew about its existence. It was almost 5,000 years ago. However, at that time it was assumed there was two different planets, one rising in the morning and one setting in the evening. Later on, the Greeks knew about that planet, and they knew there is one planet that rotates around the Sun. If you only imagine, for a long time after that, the Western civilization was denying that our own planet Earth rotating around the Sun. In the modern science, the first explorer Galileo already observed the Mercury in his telescopes. It was always too hard to see much on its surface and assume its properties from that. Today we know much more. Two explorer spacecraft visited Mercury so far, and there's one on the way who's going this day right now, traveling closer to the Mercury so it can fly by around it and send us more information about this tiny but very hot planet. So the first spacecraft that studied Mercury, it was long time ago, in 1974, it was a Mariner 10. It was the last spacecraft in Mariner series who studied the planets in our solar system. However, why it's so hard to study Mercury? Mercury located so close to the Sun, so if you send any spacecraft to the Mercury, the sun pull is so strong, so it will disturb the orbit of this tiny little spacecraft, and the spacecraft will be destroyed. Therefore, Mariner 10 traveled towards the Mercury, fly around, have sent us several photographs, and have very sparse information about its surface, geology, or any other properties. Since then, Messenger traveled towards the Mercury. Messengers give us most of the information we know right now about Mercury. Scientists elaborate the trajectory of the Messenger, so the Messenger has to first rotate around the Earth to slow down its speed, so it can go then towards the Venus. Then it rotates around the Venus a couple times, and using the gravity pull of the Venus, it could come to the orbit of Mercury. When the Messenger exhausted all the fuel it has on its board, it just crashed into the Mercury. Recently, scientists of Europe and Japan decided to send another explorer to the Mercury, which can land on its surface and give us more information, similar like we have information right now from the Mars surface. However, it's become so expensive project, they have to decline this idea. Nevertheless, in 2018, they sent the spacecraft to the Mercury without landing on its surface, but just flying around it and study its magnetosphere and surface by photographing and probing it from above. So you can see it's quite hard to study Mercury in comparison than other planets, because of its proximity to the Sun and very small size. But what we know about the Mercury so far? As I told you, it's a very small planet. There's even 2 satellite moons. In our solar system exist satellite moons. It's the satellites, like our moon for the Earth, for other planets, which are bigger than Mercury. So the Mercury is the separate planet, it's not satellite, but there's a satellite that's bigger than Mercury. However, the moon is almost similar by the size and appearance to the Mercury. It's a little bit smaller, about 1,000 kilometers in diameter. Therefore, the diameter of the Mercury is only 4,880 kilometers, and it's about 38% of our Earth's diameter. You can understand the surface area of the Mercury quite small. It's only 75 million square kilometers. It's about 10% of the surface area of our planet. So we can fit only 2 sides of the Asia continent on the whole surface of the Mercury. Therefore, by the size, you can fit 18 Mercury planets within our Earth planet, if you want to compare the sizes. However, it's the most dense planet in our solar system after Earth, due to its very high iron content. If you look through the insides of the Mercury, it looks like majority of it is the core, which is still active, in radius about 1.8 thousand kilometers, and it consists mostly of iron. Then have a thin layer of mantle, about 600 kilometers, composed of a lot of silicate material, and very thin crust, just from 100 till 300 kilometers. And this crust is solidified before the core, and geologists who study the planet's surfaces could see the evidence that there was a crust which cooled down much faster, creating ripples on its surface, and even maybe features that showing us that the planet a little bit shrinked. While we're talking about the core, let's find out, is the Mercury have a magnetic field? It's very weak. It's only 1% intensity of our Earth's magnetic field. Therefore, as I told before in previous videos about the Mars and atmospheres of the planets, you can understand it will be hard for us to survive on that surface. Overall, the whole planet of the Mercury is about 30% silicate materials and 70% of iron. That's why it's so dense, small but yet very dense. The majority of its gravity is due to this heavy iron core, rather than in our Earth we have a good gravitational pull due to the size of the planet as well. Therefore, Mercury is the planet in our solar system which doesn't have any satellites. Probably there will be any, they will be stripped away by very active sun, or be pulled away by the sun. Recent messenger evidence suggested that Mercury always have a thinner mantle and crust, because of the big drag of the sun located next to it. The theory was supported by messenger high level of materials like potassium on its surface. If originally the Mercury had more mantle on the surface and atmosphere, and due to the sun it will lose it, one day the materials like potassium will not survive on the surface. But as they say, there is very weak magnetosphere which protect a little bit Mercury's surface from solar wind, and only recently scientists could see how the particles coming from the sun are deflected by the magnetic field of Mercury. However, it's very weak, and Mercury have very big tail of the material behind it, which is stripping constantly away wherever atoms are there present on its surface. At the same time, Mercury is always subjected to meteoroids' wind. It's a very tiny pieces of meteors which less than 1 gram in weight, but they constantly bombarding the poor Mercury atmosphere. Therefore, you can imagine all these properties and the location of the Mercury to the Sun, and the fact that it doesn't have my tilt axis like our Earth. It's only 2 degrees rather than 23.5 like on our Earth. The Mercury is constantly showing one side towards the Sun and other sides towards the cold space. And there's no atmosphere, it's very small, there's no strong magnetic field at all, and it's ended up with extreme condition on the surface. Thus, there's no seasons on the Mercury at all, there's no atmosphere to retain any heat collected, and it rotates only once every 58.6 days around itself, and it revolves around the Sun every 88 days. It's very odd, it's very hard for us to comprehend. When our planet rotates 365-66 also days around the Sun in a year, Mercury rotating 1.5 times for every trip around the Sun. It means the day on the Mercury is twice as long as the year. Can you imagine that? And also there's another factor we should talk about. It's the orbit of the Mercury. It's very odd because it's located so close to the Sun. It's very affected by its pull, and it's most eccentric than any other orbit. It means it's the least closest to the circle, perfect circle, than any other orbits in our solar system. It's very elongated, and when the Mercury in the part of perihelion, the closest point to the Sun, that moves much faster. So the Mercury is kind of speed up by the proximity to the Sun. And when you're standing on the surface of Mercury, if it's possible ever, you will look in the sky. It would appear that the Sun moving west in the sky, but then stopped when you're getting closer towards the Sun in the middle of the year, and then start moving very slowly and even backwards for a few days. Then as Mercury moved past the Sun towards aphelion, away to the more distant part, its speed slowing down, and the Sun will start moving westwards back again. At the same time, the stars on the sky will look like moving much faster than the Sun. But also scientists say that the orbit of the Mercury is very chaotic, it constantly fluctuates. Some scientists suggested that even many millions years away from now, Mercury can collide with Venus. That's how it's affected by pull from the planets and our Sun. Therefore, we have very extreme condition temperature-wise on the surface. Part of the Mercury that facing the Sun can reach as much as 427 degrees Celsius. Everything will be just burned there on the surface and stay for some time. Remember, I told you it's revolved around itself more than the Mercury year. At the same time, the darker shaded part can reach the temperature below 183 degrees Celsius. The moment it's rotated back to the Sun, it's heat up very fast. There's no protection, there's no atmosphere for the surface. Scientists showing that there's a lot of impact craters on the surface of the Mercury. We'll also have some evidence of volcanic activity, some lava flows, similar like we see on the Moon. See my video about the Moon. We'll talk a little bit about geology and the forms, features you can see on the Moon. As any other planet, through the history of our solar system, Mercury was exposed to the bombarding times. There was about 2 episodes in the history when it was very heavily bombarded. We have evidence preserved on its surface, a lot of craters. And one in particular, very large, the largest crater, impact crater on our solar system, found on Mercury. We call it Caloris Basin, 1,500 kilometers in diameter. I told you this Mercury is very dense and small. Scientists find the evidence of this collision across the planet on the other side of the impact, called antipode, where the ground is very uneven and is fully grooved and have a lot of hills. Scientists suggested when it's crashed the impact, the wave of energy comes through all the planet, very dense planet as I said, creating those grooves on the other side. Today we have quite a lot of pictures of Mercury's surface. We can look at its geology, and even modern technologies can show us the images of different materials, like on these images, showing the composition of the surface. Interesting that some scientists suggested, after the messenger did research, that in deep craters, which located towards the poles, you can see it in yellow on this image, the temperature there is very low. It's never coming higher than minus 150 to 100 degrees. Because the craters are very deep and they're located close to the poles, the sun rays never reach the bottom of those craters. And some scientists suggested that solidified water must be there. From all that, and also study more information about the magnetosphere of the Mercury, we're waiting for Bepi-Colombo satellite to arrive towards the Mercury orbit, which planned to happen in October of 2025. It was sent there in 2018, and with the modern technology equipment on its board, it will give us more information about composition, chemical composition, rocks on its planet. We have better images, and we have more information about its magnetosphere and this very weak and yet fluctuated atmosphere, which we call exosphere. Looking forward for these results, to learn more about this little planet, the survivor in such extreme conditions. Venus, the Earth's evil twin planet, or the Earth's sister. Venus is the most alike planet to our Earth in our solar system, and it's the most closely located planet to our own. However, in modern day, all the scientists and engineers looking towards the Mars. Why so? What is so scary about the Venus? And why, despite all the similarities with our planet, we're not rushing to explore it? Let's talk about Venus' properties, how it's alike with our planet, and then see why it's so different nevertheless, why it has such rough conditions, and what can cause that. Venus has been known on our planet for a long time. It's back in the Mayans' times, around 650 AD, that civilization already created a very first accurate calendar using the Venus transit on the sky. Today we know Venus as a morning or evening star. It's the second brightest object on the sky after the moon. In the ancient time, Venus was called after the Roman goddess of love and beauty. However, the modern research on its surface shows us that it's quite different there on the surface from love and beauty. Often Venus is described as a twin planet or sister planet to our Earth. Not just because it's located so close to it. For example, at the time when Venus passes the closest to our Earth, it's only 38 million kilometers away from us. It is the closest object in the space that comes to us after the moon. However, Venus is as rocky planet as our Earth, and by the mass it's only 81.5% of the Earth's mass, and the radius of the Venus similar is just 650 kilometers smaller than the Earth's diameter. Both planets have relatively young surfaces, some craters, they have volcanic activity, and they both have atmosphere. However, the Venus is accounted to be the most violent planet in our solar system. The first scientist who found out that the Venus has an atmosphere was back in the day when there was a transit of the Venus in front of the Sun. It means the Venus was traveling between us and the Sun, Mikhail Lomonosov, the Russian scientist, that time observed it in an observatory in St. Petersburg. And he detected the interesting fact that when the Venus coming close to the edge of the Sun, you can detect the refraction of solar rays while observing this transit of the planet across the disk of the Sun. He inferred that from that only the presence of refraction in a sufficiently thick atmosphere could explain the appearance of a light, kind of like a ring around the night disk of Venus. This phenomena was called after him, Lomonosov, and now, many centuries after, we proved that there is a thick atmosphere on that planet. Lomonosov also observed a bulge set up at the edge of the Sun during the egress phase of the Venus transit, and he wrote that this bears witness to nothing less than the refraction of solar rays in the Venusian atmosphere. Today, when we're looking on the Venus, we can see its phases, similar like we see the phases of the Moon. You can watch my video about the Moon and learn about that. Usually when the Venus is new, not visible, this is often the closest location of the Venus to us. Shame we cannot observe it when it's the closest located to our planet. Back in 1610, the Galileo Galilei observed it already. However, most of the time we see Venus like a very bright star in the morning or evening. Why it's so bright? There's a very thick and active atmosphere, and it gives very dense color, and we cannot observe anything on the surface of the Venus, not like we can observe in average telescope the polar caps on the Mars or some features on other planets. However, on the Venus you see only the thick clouds. Therefore, for a long time people didn't know much about the Venus. What we do know about the Venus, that it has a very circular orbit, the most circular in our solar system. So it means its orbit is closer to the circle as it can. It's traveling on a distance 108 million kilometers from the Sun, and we know that the Venus is rotating in different direction than the rest of the planets in our solar system. It's very interesting and odd. Instead of anti-clockwise, like all of our planets rotating, the Venus rotation is clockwise. So the Sun rises and sets in different direction. Speaking of Sun, there's another very interesting fact, that the Venus surface rotates so slow, it takes about 243 Earth days for 1 day on the Venus. Even the year of the Venus is much shorter, 224.7 days, Earth days. That the time when the Venus makes its circle around the Sun. Therefore, the day on this planet is longer than the year on this planet. Therefore, the speed of the Sun traveling over the sky is very, very slow. If you were, for example, standing on the surface and you continue walking with the walking fast-paced speed, you can always catch up with the Sun and watch endless, eternal sunset. Scientists for a long time was wondering and curious why we have such a particular rotation and the long days on this planet. An explanation could be very simple, that on the very first years of formation of that planet, there was a collision when something crashed into this Venus big enough, even bigger than our Moon, that caused it slowing down rotation or even reverse rotation. Therefore, scientists suggested that this planet formed from the collision of two smaller planets, which impacted at such high speed that they have simply fused together, leaving very little debris. And another scientist followed the theory that the planet experienced other multiple impact events and even had one or more moons that caused the spin to reverse. Whether one or other is true, we can definitely say this is the fact that it's rotating like that and so slow, and there was some kind of external factors that caused that. Probably that was the reason that caused such a dramatic difference of conditions on that planet in comparison with our Earth. One of the facts that we do know since Lomonosov is that the Venus have a thick atmosphere. Recently we found out that this atmosphere not just thick, but it's violent and very toxic, and for us, and for everything. Even for explorers, those little satellites and rovers that we usually send on other planets to explore, like on Mars, for example. Some explorers on Mars walking more than a year now and giving us pictures, information about the soil, and other properties on the surface. However, on the Venus, through its history of exploration, some explorers only survived for half an hour on its surface and they were consumed by the toxic atmosphere, which melted the lead. But let's first talk about the interior of the planet. Is it so different from our planet, causing different atmosphere and condition? Maybe that's the clue. Well, first of all, we're not sure what's happening with the core of that planet. We do know that the magnetosphere is very, very weak. And not like our planet, it doesn't protect it at all. Knowing that we have such a weak magnetosphere, we figure out that the interior might not include the dynamo. Watch my video about plate tectonics when I describe what does it mean, dynamo. Dynamo inferred to have a liquid, more dense inner core, which will cause the convecting. So rotating fluid that conduct electricity and responsible for planet magnetic field. We already learned that Mars has a very, very weak magnetosphere, barely holding any radiation away and preserving any atmosphere. Venus might have a liquid outer core and then conducts electricity, but does not convect and rotates too slowly to produce a dynamo. Therefore, scientists assuming maybe Venus have a core all of the same temperature, because we also do not observe the active plate tectonics on its surface. Although the surface of the planet of the Venus is similar to our Earth, we even have some mountains, some evidence of the past plate tectonics. However, there's no oceans and there's numerous volcanoes, there's recent craters, and something that's showing that something happened about 300 million years ago and stopped the processes that were there before. Therefore, there's still a question, is the Venus core a liquid or fully solid? But we definitely know that the Venus magnetic field, which is incredibly weak, is caused by interactions between the ionosphere and the solar wind. Venus has the most densest atmosphere in the solar system, and the mass is dramatic. It's 90 times bigger than on our Earth. So, for example, it's equal if you diving down into the ocean, 1 kilometer depth, and that's how much pressure you will experience on the surface of the Venus, due to its thick and dense atmosphere. Very heavy and sulfuric layers of clouds, there's also a lot of carbon dioxide, enormous amount, causing about 90% of the sunlight that comes to the surface of the Venus to be refracted. There's a thick layer of carbon dioxide mixed with the nitrogen, and it's caused the most extreme situation of greenhouse effect on that planet. Therefore, the surface temperature of the planet is immense, 450 or 60 degrees, all the time, everywhere, on the day and night side. Remember we talked about Mercury, and for example, although the temperature is rising very high on the sun side of the planet, but because there's no atmosphere, almost not existing, the moment the Mercury turns away from the sun, it cools down on a very dramatic below zero temperatures. Thick layer of atmosphere on the Venus hold all the heat, trapped it like a blanket, causing the worst case scenario of greenhouse effect we don't want to have on our planet, and showing us what can happen in case of catastrophic crisis on the planet. Because of such a thick atmosphere with a lot of gases, there's an enormous rotation of the atmosphere, and we know that although the surface of the planet rotates very slow, the atmosphere rotates with enormous speed. Up to 300 kilometers per hour winds constantly operates on its surface. However, some geological evidence showing that maybe in the past the surface of the Venus was similar to the Earth, with the blue oceans and even plate tectonic. Therefore, taking in mind all these conditions on the Venus, we could figure out so it was very tricky to study that planet, although it's the closest planet to our own. And the first probe, Venera 1, to the Venus was sent as back in the day as in February 1961. The first NASA Explorer, Mariner 2, was launched in 1962, and when it arrived to the Venus, and sent back some information confirming the intense heat on its surface, as well as the presence of solar wind. The Soviet space program achieved the status of the first spacecraft to ever reach the surface of another planet with the Venera 3, so it was a third try. And before it sent any information, it's crashed on its surface. Venera 4 was the first craft that sent some information back about atmosphere and atmospheric pressure, and it did land on its surface. However, the pressure didn't hold all the research vessels to survive at all. In 1967, NASA sent Mariner 5, and it's measured the magnetic field of the Venus. Venera 5 and 6 tried to land it in 1969, but again crashed by the pressure on the surface. And in 1970, Venera 7 landed and stayed in contact with the Earth for about 30 minutes before it was destroyed. Therefore, we have numerous images from the first explorers on the surface of the Venus. NASA continued to research the Venera in the following years. Thus, on the way to the Mercury, the Mariner 10 collect some information and photos of the planet. Pioneer Venus project also was designed and launched in 1978, and the most information we got in 1989 when NASA launched the Magellan spacecraft. And it's mapped the surface of the Venus, 98% of it, using the radars, and we now understand more the geology of the Venus. The recent European Space Agency project was launched in 2005 and been sending a lot of data to our Earth about the Venus. From all these explorations, we can figure out it's a very rough condition there. To send the rovers on the surface will be almost impossible. However, scientists suggested that such a high pressure and hot temperature on its surface could be not so bad in the high levels of the atmosphere. There's a layer in the atmosphere where the conditions of the temperature will be similar to the temperate Earth's conditions. And if we manage to send the spacecraft to the Venus, dip it into the atmosphere just deep enough before these all extreme conditions, it can send us a lot of information. It can just circulate around the Venus in its winds and map it and give us other measurements from its surface. The main problem is how to sustain those rovers, actually flying rovers, and that layer of the atmosphere, collect data, and sustain such a strong winds. But what we did learn from that, all these researchers showed us the surface of the Venus. We mapped it nicely. We can see that it ranges in the height up to 13 kilometers, so a little bit higher mountains than on our Earth. We see the old remnants of plate tectonics, but we don't have any active plate tectonics operating now. We also see a lot of volcanoes. Some of them are quite big, bigger than on our Earth. Some are volcanoes of different nature. And we see craters, but all the craters are quite young and big. They're big because the smaller craters not happening on that planet. Everything been burned down in the atmosphere before it's reached the surface of the Earth. You need to have a pretty big rock to reach to the surface and create the crater. And they're all young because we see some kind of geological event happened 300 million years ago, resulted in numerous lava flows on the surface, and since then, not much happened. The surface of the Venus appears to be very smooth, maybe because of the very toxic nature of the atmosphere, which constantly moves around the planet, and secondly, deficiency of the little craters. The highland is only 10% or less on the surface, not like on our Earth, showing about the deficiency of plate tectonics or its dead state. Scientists suggested that 300 million years ago, there was probably some kind of low viscosity lava flow event, which lasted for millions of years, due to the decaying radioactive element heated up in the mantle. Eventually it was all forced to the surface. We see the evidence that the planet's still cooling down and releasing its heat from interior out through numerous volcanoes or lava flows. Lava flows covered most of the planet, and then the mantle cooled down. And because there's no more plate tectonics operated on its surface like on the Earth, we can observe it now. It's been preserved. But the most interesting and intriguing features we see on the Venus is due to the volcanism. Some features of the volcanism on the Venus we can find similar like on our Earth, for example like on Hawaiian Islands, but some of them are only we can find on the Venus due to this very, very dense and heavy atmosphere. For example, you can see these pancakes volcano craters, and they were formed from big pressure from the surface and the lava spreading in circular directions, causing this interesting feature like a pancake. Another interesting feature, arachnoids. Arachnoids, called after the spider. Spider whale-like formation crawls across the surface of the Venus. Arachnoids are a formation of unknown origin that look like concentric circles of cracked crust. They can cover as much as 200 kilometers. One of the largest craters on the Venus, it's Smith crater. It's as big almost as the biggest one on the Earth, and it's as wide as 280 kilometers. It has the inner and outer ring, and it's located north of Aphrodite Terra. There's a mountains and mounts, kind of like 8-kilometer and 11-kilometer tall mountain ridges. Some of them have caldera and cauldron-shaped collapse features. All of that indicate on a recent volcanic activity on the Venus. Therefore, scientists can conclude that the Venus is, although look alike like Earth, have similar density, similar properties, similar astronomical parameters. It's located closer to our Earth, and it's kind of within the habitat area around our Sun. So there must be life been before this huge cataclysm happened with greenhouse effect on its surface. Modern studies shows there is some interesting feature could appear in its atmosphere, and in that layer, which I said is more or less tolerable and more like on our Earth, in the higher levels of atmosphere, they might preserve some kind of organic life, and in the modern days, scientists on the way to discover that. For some time, scientists observing some interesting appearing and disappearing in the high levels of atmosphere. There's also some scientists claim that they find the phosphine in these layers of atmosphere on the Venus. Phosphine could be produced due to the activity of organisms, which is one of possibilities that there is still some kind of life in a thick and toxic atmosphere on the Venus. There's still not enough information, we still need to research it all. And the next stage will be to send these flying rovers. They're gonna rotate like a zond around the Venus in its high levels atmosphere and give us more information about is there were life on that planet and is there is life on that planet. Whatever result will be, it'll give us immense understanding of history of our solar system, where to look for the life in our solar system and outside, and our perspective as a living beings in this universe. Is Earth a unique planet? When we study the planets of our solar system, often we overlook the Earth. Planet Earth, it's a very unique planet in our solar system, and despite our approximate location on top of it, this planet still bears so many secrets for us about itself. The planet Earth in our solar system, so far as we know, the only planet can support life on it. It's rich with the beautiful oceans, thick atmosphere, rich on oxygen, and a strong magnetic field protecting the life from distracted forces of cosmic and solar energy. Let's talk about our planet Earth as a planet in the solar system and find out what is so unique about this planet and why she could home all us, the variety of the life on it, and the amazing landscape. Comparing with other planets, Earth is the one of the 4 terrestrial planets. Those that are rocky planets, we call them in astronomy. And it's also the 5th largest planet overall in our planet system. We know the intriguing shape of our planet. I had a previous video about that, you can learn in detail. Although it's common to understand that it's spheric, we know it's slightly flattened at the poles and bulgy at the equator. And it's all due to the forces of rotation of our Earth around itself. Therefore, the furthest point on our planet from its center is located in Ecuador, rather than in Himalaya, like you would think. We know that the density of our planet is quite high, 5.52 gram per cubic centimeter, and its circumference about 40,000 kilometers. Let's talk about some astronomical properties of our planet, which are determine the particular seasons on our planet, day, night, and all the cycles which we observe. First of all, we know that Earth rotates approximately 24 hours around its own axis. Although the true length of the solar day is slightly varies, we custom for that. Thus, the Sun rising up over the horizon and setting down is slightly different than the rotation of the planet around itself. Therefore, we have this slight difference of days, and we accounted for this extra time every year into the leap day once in the 4 years. Orbit of the Earth is eccentric, elliptical one, and it's as well affecting our seasons on the planet. The Earth rotates around the Sun every 365.3 days. We know that in the summer, the northern hemisphere receives the most direct sunlight during the summer months, resulting in the hotter temperatures on the planet. While during the winter, it's the coldest months, because the sun rays have further to go reach the Earth's surface. We have reversed seasons in the southern hemisphere. However, the position of the oceans in the continents different from northern in comparison with the southern hemisphere, affecting the heating of the oceans, heat distribution, cooling of the planet, and therefore we have such a different seasons comparing northern and southern winters and summers. Another very important fact about our planet is about its axial tilt. It's about 23.4 degrees, meaning that the northern and southern hemisphere are exposed to the sun at the different times. And that's how we have the 4 seasons. In some places 4 seasons are more pronounced, and some seasons they smoothed by their proximity to the ocean or the sea. One of the most important and intriguing characteristics of our planet is the presence of the satellite, the Moon. Although many other planets in our solar system have moons, even several, our Moon is very unique, and we have specific relationship with the Moon, and it has the measurable effect on everything from our climate to the length of our year. Scientists say that the Moon is kinda tidally locked to the Earth. It has a rotational period that the same length as it takes to orbit our planet, and it's mean that we're always observing always the same side of the Moon facing towards us. And before people fly into the space and move the spacecraft around the Moon, we didn't know what's happening on the other side of the Moon. It was a mystery. The Moon is moving away from us at the rate of 38 millimeters per year, so the space between us and the Moon increasing. But however, if you think the tides solely depends on Moon, it's not true. We have a complex relationship between Moon, Sun, and the Earth's rotation. Yes, Sun play a big role. It's quite proximate to us, and it's so big it has huge gravity pull, so it's affect the Moon pull and affect our life on the planet. Many scientists suggested that not only the rise and fall of the tides caused by these interactions, which actually not only happening in the water, we just observe it very nicely in the water, it's also happening in the crust of the Earth, the lithosphere, the solid crust. But also, this interaction keeping the Earth's tilt stable. Thus, for example, if we didn't have this Sun, Moon, and Earth triangle, probably the tilt of the Earth will move from million years to million years and have some kind of chaotic changes. Because of the size of our planet, its composition, density, we know that our planet have a good gravity pull, preserving our atmosphere, heterosphere, or the oceans, and ensuring the life on our planet. We know that average we have about 9.81 meters per second acceleration of freely falling objects close to the Earth, like Newton discovered on example of the apple. However, these gravitational forces are slightly different across the planet. At the equator it's slightly lower, 9.78 meters per second, and towards the poles a little bit more, 9.83 meters. Similar if you're going higher into the mountains, for example at the top of Mount Everest, about 8.8 kilometers height, you'll weigh about 0.3% less than you will weigh at the sea level. And the more you're traveling into the higher levels of the atmosphere and outside of the orbit of our planet, this pull will decreasing. Thus, scientists suggested that the Sun's is so large and its gravitational pull is the half those of the Moon, despite its distance from the Earth. Therefore, at the first and the third quarter moons, the Sun and Moon are in opposition and produce neap tides, which are lower by its amplitude. And the higher amplitude tides are produced during the times of the new moon and the full moon. Now you know why you're so affected by those times of the months. In my numerous previous videos, we talked about the formation of the solar system, where we discover how the Earth was formed. We learn about interior of the planet, some particular geological features, composition of this planet. We'll just briefly go through that, and I will say that our Earth is composed of the core within metal, mantle, crust, and atmosphere. Some also suggested we have a biosphere, all the life forms that in a thin layer of lithosphere and atmosphere close to the Earth. It's interesting, the Earth is quite different just because we have inner and outer core. Inner core is solid and the most heavier, and the outer core is liquid. And they both mostly contain iron and nickel, very heavy metals. It's very hot, 6.7 thousand degrees in Celsius in the center, and the heat is produced there by radioactive decay, and 20% of the energy comes by gravitational binding of the planet. We know that the planet in its just formation was much hotter, and now it's slowly cooling down. This cooling down causing these processes on its lithosphere, the surface. Volcanic eruption, spreading mid-oceanic ridges, and the formation of our crust on the surface, which we observe right now. Our planet is a solar system produced from the explosion of the nebula, so we are built from the remnants of previous solar systems and stars. And majority of the minerals composition on our planet is so numerous, all different elements. However, 99% composed only from 8 elements, such as iron, oxygen, silicon, magnesium, sulfur, nickel, calcium, and aluminium. This is the most common elements you will find on our planet. We know that our planet, during its formation, experienced a fact. Very important one, it's when the moon actually crashed to our Earth. There's numerous theories when and how it happened. However, we know there was a fact, and we still experience right now on the surface of our planet. There's also numerous asteroids, comets, and other objects that passing by bring water and other elements on our surface, and some even suggested they might bring the life. We know about the initial atmosphere, how it's formed. Watch my video about the first atmosphere on our planet. And we know that today the atmosphere composition about 78% of nitrogen, 21% oxygen, and some other elements. This is so important for us because this is most comfortable for us to breathe and stay alive. We have the layer of ozone that blocks ultraviolet radiation from the sun, and it's also creating this kind of greenhouse effect. Greenhouse, it's like when you cover with a glass jar your little tomato, creating local heat. Heat waves coming through the glass, but they're not escaping as easy. That helps to sustain the life on our planet. However, we know that it's so sensitive and intricate system. If it's too much greenhouse is affected, you might kill the life. If it's not enough, you might kill it from overcooling. Therefore, our planet is just perfect for today for us to strive. And the atmosphere and all these properties are all possible due to the layer of magnetic field, upper layer of our atmosphere. It's protected the gases in the atmosphere from being shared away and carried off into the space by solar wind. And our magnetic field around our planet protect us from destructive action of radioactive particles coming from the sun all the time and from the cosmic deep space. One of the most important and distinctive about our planet is that we have plate tectonics. It's ensure we have these two different cores on our planet, oceanic, covered with the ocean mostly, and continental. We have the movement of these plates constantly through its history, changing the climate, changing the regional geology, changing the regional geography, changing the life adaptation. Also, we have opportunity to build the tall mountains and create the ice caps. All that is due to the plate tectonics and all these interactions between interior of the planet, gravitational pull of the sun and the moon, and the cooling of the planet with time. Therefore, we have such a big diversity of geographical features on the surface of our planet. We have volcanoes, rift zones, deep trenches in the ocean, flat areas, deserts, rainforests, beautiful oceans and seas with the coral reefs, and the numerous ice caps, which preserve the fresh water for us. If you only look at how many different places you can find our planet, how colorful and diverse they are, you'll be amazed. So far in our solar system, we don't observe anything like that and that variety on any of other planets. Thus, if you have some kind of alien arriving to our planet, what you will show to them? You will show the beautiful and the most largest rainforest in Amazonia. You will show the most biggest and active in terms of volume and area volcano in Hawaii. You will show the biggest crater that preserved right now on the surface, about 300 kilometers in diameter, located in South Africa near Johannesburg. We will go take these aliens to see the deepest canyon in Tibet, which reach up to 6 kilometers in depth. You will show the tallest waterfall situated in Venezuela, Angel Falls, standing almost up to 1 kilometer of the uninterrupted waterfall on our planet. Of course, you're going to show the biggest ice sheet in East Antarctic, the largest glacier, Antarctica Lambert Glacier, more than 100 kilometers wide and as deep as 2.5 kilometers down. And of course, our visitors will see themselves the highest peak on our planet, Everest. Although there's features around within our solar system which are higher, bigger, for example on the Mars we have much higher volcano up to 30 kilometers, bigger craters on other planets and so on. However, it's amazing that we can find it here on our planet on such a small area. So why it's there life is possible on our Earth and why it's there right now? Everything I just talked about, its astronomical position, size, rotation, interaction with the Sun and the Moon, other planets, the way how the planet was formed, its interior, its magnetic field, the plate tectonics on the surface, particular gases composition of the atmosphere, its preservation due to the magnetic field size and so on of our planet, and of course the position towards the Sun, which is, although the most given in our solar system of the terms of energy and heat to everything in our solar system, therefore could be the most destructive. Putting all this together, our planet astronomical properties ensure that the life could not just develop on our planet, but also survive through millions, even billions of years and strive. Astronomers called this position in the solar system, in any star system, the Goldilocks zone, the place, the distance from the main star, which is capable of retaining water with atmosphere and therefore potentially can have a life in it. All known forms of the life require liquid water, so it's the main standard for finding life on other planets. But the planets need just more than the water. For example, we have other planets which have plenty of water. We don't observe any particular life striving there. Earth just have right amount of reasons to have a life on it. Atmosphere is the first, required oxygen-rich air, so you must have a particular magnetic field to sustain and preserve those light molecules of the oxygen. For example, if we didn't have atmosphere right now, our average temperature on our surface of the planet will be minus 18 degrees. Today, just because we have the beautiful atmosphere, it's plus 15. And thanks to our gravity and magnetic field, we do have it on our planet. Sun, very important factor, its distance from it, just amount to preserve the life on our surface. Sun is also a very important factor. We need to have perfect distance for this temperature and heat levels. Sunlight is very important. We can have too much sunlight or not enough, like on other planets in our system. And one of the important things which we shouldn't forget about our planet, that we have the water cycle. Water cycle is this exchange of the water between hydrosphere, oceans, and all the water bodies on the surface, soils and forests, into the atmosphere, and then coming back on the surface of the Earth. You would say, oh, we just discovered the water on the Mars as well. It's there. Why there's no striving life? It's very important how you find the water. It should be in a liquid, gas, in a solid form. And as I said, for example, plate tectonics ensuring preservation of the water in the ice caps. It's ensuring the water cycle, moving of the water throughout, and constantly supplying all the life, plants and animals, with the fresh water all the time. We are humans, composed of 70% of the water. We need that water to be available to us all the time. Our planet is breathing, it's alive. It might have all those components and elements, but it could be dead, with no life. Our planet is alive, plates are moving, lithosphere is very active, volcanoes erupting, waters flowing, glaciers melting and freezing again, and alive, striving because of that. Let's don't underestimate our planet, how providing she is for us and how giving and supporting our planet for us. And before we rush to any other planets, establishing colonies there, polluting our planet and forgetting about our own home, let's first ensure that our planet can continue being alive and continue giving and supporting our precious life on its surface for next not just millions but also billions of years. Mars and its secrets. Mars, so-called red planet or the bloody planet, the fourth torrential planet from the Sun, is actually one of the smallest planets, only second one after the Mercury in our solar system. However, this planet bears a lot of secrets. It's one of the planets which whole humanity looking for a long time, and it's the most popular planet in the recent media about exploring and potentially colonizing. Let's in this video talk about some secrets that Mars bears, how it's similar with our planet Earth, what are the particular features and why we can find on the Mars. We will see the data from recent research and rovercrafts that exploring intensively Mars for last several decades. To understand the particular features which we observe on the surface of the Mars, its conditions for potentially life which can be there or life which could come there and colonize it, in terms of us, people, we need to just briefly discuss the main properties of the Mars, which state it is on now, and how it's comparable with our planet, Earth. Since first telescopes were invented, people were observing the surface of the Mars already from the Earth. Back in the time, people observed particular lines on the surface of the Mars, changing ice caps, and were convinced that there must be some civilization already there. A lot of science fiction arose at that time, and people were sure that some canals were built on the Mars, this planet is occupied by Martians, and has similar conditions that on the Earth. However, the exploration of this planet in the 20th century showed that it's not quite true. The Mars surface preserved more bare land. Heavily bombarded by numerous meteorites, the surface of the Mars more dead appearing than we would like to think. This planet was formed at the time when our planet formed and majority of the planets in our solar system, about 4.6 billion years ago. We know about the volcanic activity through the history of the Mars, especially in the beginning of its life, which actually released a lot of heat from the core and cooled down the planet quite quickly. And we know that atmospheric water was likely in a frozen condition, although it was preserved, but very fast it was swirled away by solar winds due to the very low atmospheric pressure and almost non-existent atmosphere there. Revisit my previous video about Mars colonization, where I talked specifically about atmosphere, why there's such a weak atmosphere on that planet. And eventually, nevertheless, there was a water on that planet, or still preserved only in a frozen state under the ground. The Mars today is the very dry and dusty planet, quite cold at times, and it's been like that since we people were observing it. Therefore, Mars appeared to be very similar to the Earth planet. However, there's a dramatic differences between us and the Mars. It's a similar terrestrial planet and has almost identical geographical features and a similar axial tilt, which resulted in the seasons on the Mars. However, it has basically no atmosphere, no liquid water, and wildly fluctuating temperatures on the surface. Although for us the Mars appeared to be a very red planet, we see the snow-capped looking poles, which mostly consist of dry or frozen carbon dioxide, and the water underneath. And actually, if you observe through the seasons of the Mars, these ice caps, they will be changing, similar like on our planet. In comparison to the Earth as well, Mars is about half the diameter of the Earth, and much less dense. That's why we have weaker gravity. In fact, the mass of the Mars, it's about 11% of Earth's one. But because there's no oceans of the Mars, it's just one land everywhere, it has the same amount of dry land as we have on the Earth. Mars is a little bit further from the Sun than the Earth, about 228 million kilometers, which fluctuate, of course, depends on its movement along the elliptical orbit. Because of that, it takes longer, about 687 Earth days to orbit the Sun, almost twice as long as for us to rotate around the Sun. And its orbit is the second most eccentric in the solar system after the Mercury. However, scientists believe that in the past, probably Mars have more rounded orbit, and it's changed due to gravitational influence from Sun and other planets, particularly Jupiter, a very big planet. As we said, the tilt of the Mars is close to our one, 25.19 degrees, in comparison with 23.44 degrees for the Earth, and it's mean that we have seasons there. However, the seasons a little bit longer on the Mars due to its longer travel distance around the Sun. We observed 2 satellites orbiting around the Mars, and actually those satellites, it's the asteroids that have been trapped, or maybe material that have been ejected from its surface due to the impact and stay on its orbit. Therefore, there's 2 very small satellites, nothing in comparison with the Moon, Phobos and Deimos. For example, Phobos is rotating around the Mars on distance about 6,000 kilometers, very close to it. And it's very small, its radius only 11 kilometers. It's not circled like the Moon, it's very irregular of the shape, and it's actually have them impact craters on its surface. Deimos even smaller and more distant from the Mars, rotating around on a distance about 23.5 thousand kilometers away from its surface, and its radius about 6 kilometers, very small. These 2 satellites, small although we know they're there, scientists suggested maybe there are some other bodies that rotates around the Mars. They've been trapped similar by its gravity. Therefore, we can conclude that all these similarities and differences between the Mars and the Earth caused such a different condition there. So you can say Mars is maybe the future of the Earth. scientists suggested this planet had the plate tectonic and active volcanism on it, like we do have right now on our planet. However, it's exhausted itself, and volcanoes we observe on its surface are dormant now. The location of the volcanoes suggested that plate tectonics actually took place in the past. And also the differences, for example, difference between northern and southern pole suggested different crust mantle there. Maybe because this planet is smaller and it's exhausted itself much faster than our Earth. For example, the core cooled down much faster. It's caused all these problems with magnetic field around it, loss of atmosphere, the water, very important for life, and as a result, faster loss of other minerals, high radiation on the surface, which resulted all in such a dead appearance for life right now. However, some recent researchers suggested maybe there's still some kind of form of life preserved in the ground, under the ground. Similar like in our Earth, we have so much microbial form of life within the crust of our Earth, in the caves. Similar, we might find something leftovers on the Mars. However, we need better equipment that could climb into the caves on the Mars, which will go there in the future. Nevertheless, for life forms like animals and humans, Mars is not very convenient. The gravity, atmospheric pressure, radiation, and very low temperatures, all that will cause, if not immediate, but soon death on its surface. All these features end up in particular surface on the Mars, which we observe now better. Before, as I said, people observe only particular lines on the surface, but the moment when we start orbiting around the Mars, photographing it regularly, and now even walking on it in forms of rovers, special machines, of course not humans yet, it's revealed us a very interesting geological features on the Mars, which make us think more about the Mars like the Earth, or the Mars like the Earth in the future. High quality pictures and observation of surface of the Mars, which we can see 100%, not like we can see on our Earth. Earth is covered 75% with the water, so majority of the Earth's surface we never seen in real life. But Mars, it's all exposed there, and when the caps on the poles are melting through the seasons, we can see more of the surface of that little red planet. Majority of the Mars surface covered with regolith, loose conglomerate of broken rocks, dirt and dust. And because there's not much atmosphere, the solar wind strips away molecules into the space. Therefore, about 95% carbon dioxide, 3% of nitrogen, and 2% of argon, with other gases, right now, kind of composition of the Mars atmosphere, remnants of this atmosphere. And in this very poor atmosphere, we observe ice clouds, mostly made of carbon dioxide. Let's talk about some geographical features on the surface of the Mars. The biggest one is that the Mars has increasingly different northern and southern hemisphere, as I said. Most of the northern hemisphere is lower in elevation than the southern one, up to 6 kilometers. It also has far fewer impact craters, so it's smoother and more uniform surface, explaining that the crust in the northern hemisphere appears to be much thinner than in the southern one. Therefore, we cannot explain exactly why there's such a difference. We can suggest that volcanic activity, tectonics, and impacts, it's the main processes that affected the surface of the Mars we see right now. The most striking features you can see on the Mars, it's the mountains, which are sleeping volcanoes or inactive volcanoes. We have two areas, Tharsis Bulge and the Elysium volcanic complexes, which contain several volcanoes grouped together. Tharsis Bulge covers about 25% of the planet's surface and lies 7 to 10 kilometers above it. And here we can find the Mount Olympus, a shield volcano that's the largest mountain or volcano as well in the solar system. Mount Olympus is very large and it's as high as 22 kilometers, which is more than 3 times higher than the highest mountain on our planet. You can maybe explain it that the gravity is not as strong there. It's only about 40% of the one we have on our planet, and it was easier for material to bulge and build up. It also can suggest much stronger internal forces back in the ancient times of activity on the Mars. As I said before, scientists suggested there was no plate tectonic on the Mars. However, very recent discoveries on its surface shows that there was plate tectonic. We see a lot of steep cliffs, flat walls, canyons, and we see the faults at work. And also we observe the Mars volcanoes are concentrated in two different areas. The large valley system, known as the Valles Marineris, is the deepest in the solar system as well. Take up a quarter of the planet's circumference. It is, in fact, a plate boundary as well. There is a horizontal movement along the plates. We know just about that fault system very well on Mars so far. The scientists believe that the Mars tectonic system is much younger than on Earth. We observe numerous impact craters and basins on the Mars southern hemisphere. For example, Hellas Basin is the largest, and it's about 1.8 kilometers in diameter. Scientists believe that it's old as 3.8 billion years, which is dated back to the period of heavy bombardment of the Mars and other planets, also our Earth and our solar system. And of course, the ice caps at the poles, which changing with the seasons, as I said. We observe 4 seasons on the Mars. They are just longer and of varied lengths. Temperatures can get as low as minus 143 degrees Celsius at the ice caps in the winters, and the ice beneath the surface freezes and melts depending on the temperature. We know that carbon dioxide, which observed on these ice caps, melting points much lower than for the water. So when the all carbon dioxide sublimated from the surface, we can observe the frozen water there. The atmospheric pressure on the Mars is much lower than the Earth as well, and it's so thin that there is very little to block the surface from the sun's heat. There are ice clouds, probably caused when the wind kicks up dust, while one of the red planet's biggest weather features is dust storms, which can last up to months. We observe some water erosion features on the surface of the Mars. Real Valles is one of the valleys on Mars that looks as though might have been carved out by the water movement. Many of these valleys contain grooves on the floors that may be rich in iron. We observe the sand dunes, made of regolith, a mix of soil, sand, dust and broken rocks, which drifted into dunes on Mars' surface. Scientists once thought that they were stationary, but observations have shown that the dunes actually move due to prevailing winds. And of course, every day we're receiving more high-resolution images from the Mars, and there's so much to study for geologists on that interesting planet. Maybe one day our Mars craft will go down into the craters or canyons and sample the rocks within from the slopes, and it will tell us more about geology, history and life on that planet. I hope in this short video you get some interesting information about the Mars. However, keep in mind not just the similarities to our planet and how it'll be interesting to visit it, but also the differences. Mars, the one planet which just started leaving the inhabited zone around our Sun, and the temperatures on this planet a little bit too low for us to strive like we do on our kind and beautiful Earth. However, it doesn't mean we shouldn't explore it, and future century will be the Mars century in terms of exploration of other planets. Please subscribe and watch next videos about cosmos, our solar system, and of course about our own home, planet Earth. Mars, colonization of Mars. Let's talk about Mars colonization. Why we're still not on Mars, when more than 50 years ago people were walking on the moon? What's the problems with colonization of the Mars scientists and researchers, engineers facing these days? What's the main problem we'll face when we land on Mars? Let's talk about that. Mars, one of the 4 terrestrial planets in proximity to the Earth, located in the habitat spectrum close to the Sun. It's not as violent and aggressive as Venus, and it's not as hot as Mercury. It has some similarities with the Earth, and for now, up to date, it's the most inviting planet to colonize after the Earth. But so far, not human footstep on the Mars. Why? Let's first talk about the Mars' main physical properties that doesn't let us to go there right now. First of all, the main problem on the Mars right now for human being is that it doesn't have geomagnetic field. The geomagnetic field is so important for the organisms living on any planet, like we have on the Earth, to create the protection from sun radiation. If you watch my previous videos about the Sun solar system, you will learn that all planets in the solar system are under the influence of wind radiation. So to speak, we are located in the Sun atmosphere. What it does do, it's constantly bombarding us with radiation, with the rays coming from the Sun. And if we have any particular events happening on the Sun, like burst of sunspots, we have the wave of big radiation coming towards all the planets around it. Planets like Earth will be protected by our geomagnetic field, although we still might experience some interruptions in electricity or effect on the human health due to this outburst of the Sun activity. Imagine if we didn't have atmosphere and geomagnetic field like happening right now on the Mars. It's for sure will cause deadly disease for all the life organisms or even death. That's what waits for us on the Mars. Mars has a core, and it's mostly composed of iron and nickel, but unfortunately this core is mostly solid right now. Some scientists suggest there's still some liquid parts of the core, but most of it's solidified a million years ago or more, and it stopped producing geomagnetic field around the planet. As a result, wherever there was the atmosphere before, which we will study in the future by exploring the deposits on the Mars, it's not there anymore. Constant solar wind stripping away all the molecules and particles of the surface of the Mars atmosphere, and have very, very weak layer of mostly carbon dioxide air, 95% of which is composing the modern atmosphere. The rest 5% it's nitrogen and argon gases, and some less than % traces of oxygen in the atmosphere on the Mars. Therefore, you understand, for human and any other life forms that will come to the planet Mars, it's impossible to breathe the air there. Just because of the smaller size of the Mars in comparison with the Earth, it's about twice smaller diameter of the planet. However, there's no oceans, so most of the territory is the land. It's equivalent to the land that we have right now on the Earth, just because we have about 28% of the Earth's planet as the land, the rest of it is the ocean. Surface of the Mars, it's almost equal to that. However, because there's no atmosphere, no geomagnetic field, there's much more rough condition in terms of temperature. We have ocean and thick atmosphere on the planet Earth that protect us from overcooling when we turned away from the Sun, and protect us from overheating when we face towards the Sun. On the Mars, different story. Mars is mostly reddish color planet due to high percentage of iron and oxygen in the surface, giving this rusty red look. And wherever sun rays falling down on the surface, they heat up the surface so much, and there's no big atmosphere to trap the heat. So when the night happens, when the Mars turned away from the Sun, it's cooled down up to minus 60, 80 or even 120 degrees. It's cooled down straight away dramatically. For life forms, apart from extremophiles, the life forms that like to live in extreme conditions, this is basically deadly. So if we will want to live on the Mars, we should spend most of our time in the shelters or under the surface, where the temperature will be more uniform. Apart from the atmosphere composition, we can wear scaphanders on Mars. Apart from different gravity, it's slightly smaller than on Earth. On Mars, about 37.5% of the Earth's gravity, so you feel 3 times lighter when you're on Mars. Will have effect on your bones and muscle structure and blood pressure and other vital processes in your body. However, you can deal with that if you stay not too long on Mars. But the most deadly effect you will have from the radiation coming from the galactic space and the sun. There is no protection from those events there. And recently the rovers on Mars find that the radiation on Mars exceeding our expectation at least 2 or 3 times. And when we have big events on the sun, the radiation exceeded 25 times our expectations. After that event, more probably the life form will die, who are not protected from radiation. So the main problem you will face with when you stay on Mars, apart from air you need to breathe, no water, there's only sparse water found under the ground. Cooler temperature, you can protect yourself, but from radiation you'll have to hide under the ground. Regular storms on Mars, when difference in the temperature caused huge wind current and as a result intensive dense storms on the surface. You can observe in this video Mars without the storm and through the storm, when we absolutely can see any surface on the whole planet, will have impact on communication and exploration and colonization of the Mars. However, even this we can overcome. There is no technologies yet exist to protect us from space and sun radiation on Mars. That will be the main problem why we're not sending people right now on that planet. But imagine we'll find a way staying under the ground on Mars. However, you need to get till the Mars. Nevertheless, it takes about 8 months or so to travel from Earth till Mars, one way. So you have to spend 16 months in the open space. When we're traveling into the space to the space stations orbiting around the Earth, we're still protected from galactic space radiation, we're still protected from sun radiation by magnetosphere or geomagnetic field of the Earth. Physically, Earth shelters us from sun and space radiation, at least from one direction. And the old space station, they're just floating in the higher levels of the atmosphere where there's still protection by geomagnetic field of the Earth from radiation. And still, people have limitation. We can't spend more time in the space station when it starts exceeding radiation in your body, and you will have to reduce your dosage by going back on the Earth. With traveling into open space, there's a different story. There's absolutely no protection, not from the Earth in any other planet. And the space travelers will be absolutely exposed to 2 types of radiation there. The average amount of this radiation that will people be exposed to the traveling from Earth till the Mars will be exceeded the normal dosage for preserving the health of these people. More probably problems like cancer, other disease, or just permanent damage to the tissue in the body will be the result of that. The spacecraft we're creating these days not good enough to protect us from that radiation. So we're still working on technologies to create bigger, larger, huge spacecraft and new technologies to protect people from radiation during the travel. But it's not feasible these days, and it's not going to happen in the next 10 years, realistically. And remember, you have to stay on the Mars some time. You're not going to travel there to stay 1 day on that planet, and you have to travel back. Therefore, there are too many problems with radiation for us to travel to the Mars these days or during the next 5-10 years. There is a proposition by NASA or United States government by 2033 the human will be landed on the Mars. Researchers, engineers putting a lot of money and efforts to develop technologies to do so. However, you need to understand realistically that in the modern economical situation on our planet and with modern technologies, it's probably not going to happen so soon. It's more reasonable, effective cost for us to send the robots who are affected by radiation, but they're not humans. They can stay there for many years and perform research for us on the Mars surface without putting in risk human lives and spending enormous amount of money to building sophisticated crafts and building sophisticated shelter on the Mars to stay several people there. Although it sounds so amazing, one day, soon enough, we will land on the Mars. There's other problems with that. If you look in the history of Mars exploration up to date, we see that it's following by a lot of failures. Since 1960, about 43 spacecraft attempted the missions on Mars, and only 14 finished the missions was successful. There are problems with communication with the Mars. There's problems with environment on its surface, very cold temperature, toxic soil for any organisms and human being. Therefore, we can't find yet the life on its surface. However, there could be some life under the ground, deep down, but we can't dig so deep yet using the rovers we have these days. There's problems with navigating the spacecraft so they successfully land on the Mars, and they continue get the sun radiation, so the solar panels keep feeding the batteries, and it's not always going well. With the human mission, it'll be too high risk to send people to explore the Mars with the current situation we have. Another big problem, which many people not think about, it's the contamination of the Mars with earthly bacteria and life forms. We're already landing the spacecraft and other equipment on the Mars, and there's several spacecraft orbiting the Mars, and probably it's already happened some contamination of the Mars. However, because of this toxic environment on the surface, or probably if any bacteria survived the travel till Mars, they probably died there. As I say, there's this type of organisms, extremophiles, who can preserve in very, very extreme condition with high radiation, or at least the type of zygotas or forms they preserved and wait for the better condition to start the life again. With colonization Mars with humans, we need to surpass this understanding that we're going to bring life forms to the new planet, and it will cause huge ecological problem for that planet. Therefore, colonization of the Mars sounds very intriguing, exciting, and comforting, knowing that our Earth planet will be not the only place where we can live in case of any catastrophic events, ecological events, or big asteroid impact on our planet, which can destroy our civilization. And even though it seems like colonization of ours just on the tip of our fingers, just here, we're already ready to do so, there are too many problems, economical, ethical, physical, just engineering problems to go there, that for now, I think it still stays as a beautiful idea rather than tomorrow's reality. Is Jupiter a failed star? Jupiter is the biggest planet in our solar system, and it holds so many secrets. Its violent nature, gas composition, and the fact that it's twice bigger mass than all the planets in our solar system. Let's first talk about parameters of this planet. This planet has diameter 11 times bigger than our Earth's diameter, about 142.9 thousand kilometers. And this planet is the largest and has the huge magnetic field and 64 moons and natural satellites that evolved around it. Many consider Jupiter as the miniature solar system, and it looks like that. Often people say that Jupiter is a failed star because it's made of the same gases as Sun, although it doesn't have anywhere near the mass or temperature to actually be a star. Jupiter needs a much bigger mass, about 80 times of current, to become a star. Back in the day, Galileo was the first to see the 4 biggest moons of the Jupiter: Callisto, Europa, Ganymede, and Io, which evolved around it. If you looked in any not that strong telescope or binoculars, you can see on a clear night those 4 satellites. Jupiter is innermost of the 4 gas giants, and we know other ones: Saturn, Uranus, and Neptune, the gas large planets bigger than our Earth. Although they're very gassy planets and large, they're not as dense as our Earth-like planets. but the closer you get towards the core of those planets, the gas get more denser. The Jupiter mass as well is enormous, 317 times of the Earth one, and 1,000th part of the Sun. Interesting that when the Jupiter was formed, it was actually much larger than now. It's been shrinking and shrinking every year 2 centimeters. The process of heating and cooling of this gas causing such a rapid shrinkage. We know that the Jupiter actually evolving not directly around the Sun's center, but slightly to the side of it. The center of the mass for the Jupiter lies outside of the Sun, and although Jupiter is large in diameter and mass, it's not as dense, and it's about only quarter of the density of our planet. Interesting that Jupiter orbits our Sun around every 11.8 Earth years. It's tilted very small, only about 3 degrees. So we do not suggest that there is a seasons on that planet, if the seasons could occur. It's such a gaseous planet. However, it rotates very fast. It's the fastest in all the planets. It rotates around its axis every 10 hours. Therefore, the planet is bulged around its equator, and it has the shape of an oblate spheroid. Because it's so gaseous, not all of the planet orbits at the same speed. And you can imagine it has 3 different systems. The atmosphere at the poles rotates around 5 minutes faster than the equatorial atmosphere, which is a little bit slower than the rotation of the magnetosphere. Jupiter, it's not just about its size and the gas. It's a very interesting appearance. It's have a lot of red, orange, white and brown bands. They move separately from each other. And the Jupiter is the 4th brightest object we might observe now on the sky for today. It's interesting that we cannot see whole the surface of the Jupiter. The angle of the light reflected from the Sun is never greater than about 11 degrees. So to see the whole planet, we have to go and visit it. We also observe Jupiter to move in retrograde manner in respect to the stars, and it's because the Earth overtakes Jupiter during its orbit once every 398.9 days. Let's talk a little bit about the structure of the Jupiter. Because it's a gaseous planet, it's mostly about atmosphere. These gases get denser, hotter under the great pressure within, the closer you towards the center. Jupiter consists of 90% of hydrogen and 10% of helium, volume-wise. But in terms of composition, there are about 75% of hydrogen, 24% helium. We will also find other elements such as ammonia, methane, carbon, hydrogen, sulfide, and other elements and compounds. We don't know much about its interior because we cannot penetrate through its very thick cloud of atmosphere, about 150 kilometers. However, scientists believe that the rocky core containing silicates and other elements will be in the center of this planet. This conclusion based on gravitational measurements taken by probes, but this model is very uncertain, and we're waiting for new data coming to us from future exploration of this planet. We know there's a big spin of the temperature on this planet. For example, in the cloud layer, it's about minus 145 Celsius degrees. It's very cold. However, the more you move towards the central, hydrogen becomes liquid and the temperature reaches 9,000.7 degrees Celsius. The core could be about 30,000 degrees Celsius. The planet is thought to have been much hotter and also much bigger, as much as twice of its current diameter when it's just been formed. And we know that Jupiter generates a lot of heat, much more than other planets, and it produces as much as heat as it's receiving from the Sun. What's interesting about the Jupiter that we're not sure if there are any and how it looks like the surface on that planet. Everything we see up today is the thick layer of the clouds. Let's talk about the clouds of this planet. Even from weak telescope you can observe these bands on its surface and even the red spot, one of the biggest swirl of the storm we ever observe. We know that these cloud layers are not static and they constantly move and flow. They have very complex pattern. We can see the bands of two kinds mostly, light-colored ones and dark-colored ones. The brighter ones, it's ammonia ice clouds in high areas and they're cold, while the dark belts contain thinner, lower, warmer clouds. The red and orange colors come from sulfur and phosphorus, while carbon may create some of the lighter gray colors. We can see the zones of these clouds all over. We have equatorial zone. We see the equatorial belt extending from equatorial zone towards 18 degrees north and south on either side. We see the tropical zone and less distinguished one towards the poles. We don't see any perfect boundaries between these layers. And since we're observing precisely these belts and the movements within those zones, and even the red spot, we see that they're quite constant. At the same time, there's temporary changes happening within them. Sometimes the speed of the wind changes, sometimes appearance changes. Scientists suggested that the speeds could reach up to 100 meters per second, very high speed. And therefore the Jupiter doesn't have seasons, as we find out. It must have very strong weather patterns. The evaporation and condensation process of water creates dense clouds. These are strong storms, including powerful lightning strikes, mainly in the belts. The majority of the storms there tend to be very short, but there are a few major storms that have been raging for a long time. The biggest one, we know, it's the Great Red Spot, which have been around for at least 300 years. And there's also, we know, and next to it there's a smaller red spot. Some refer it as the Red Spot Junior. Is there changes occurring in this red spot? Oh, it's quite stable. Yes, since we're observing it, we have quite consistent readings from about 1979 till today. This storm is about 12,000 kilometers wide north-south and about 24,000 till 40,000 kilometers east to west. Some suggested that originally this spot was much bigger. Its shrinking doesn't mean it's going to disappear. These clouds that make up this spot are high and they're much colder than surrounding clouds. The darkest, reddest areas in the center is significantly warmer than the rest and actually has a mild clockwise rotation. So we see the variation with the clouds within the spot. Sometimes they're strong, dark red and orange, and sometimes they're pale. So why this red spot stay for so long? We don't know. One theory that it's continually powered by the intense heat from the planet and there's no land masses or other formation to disturb it. And maybe it's also have been absorbing other storms in the past. One interesting fact I hope you will learn after this video is that the Jupiter has rings too. We always think about Saturn or Uranus with the rings, but actually since 70s of the last century we discover that Jupiter has his own hidden ring system. We have two outer rings, they're white, and they're named after the moons that connect to them. And material in these rings, some of them made up of particles coming off the tiny moons located within them, while some of the ring likely formed from particles sucked towards the planet from the main ring, which mainly composed of dust. And that's mostly what we know today about this planet, and there is so much to learn about this planet. We have no idea how its surface looks like, what it's composed of. Some suggest that there's no actually border between atmosphere and internal material. Therefore, you kind of just dive in through the atmosphere into the denser atmosphere before you reach the core. There is so much to explore, and future exploration will give us so much information. It's fascinating how many answers future hold for us about our solar system. Please like this video and subscribe to my channel to promote my videos. And I hope I'll see you in the next videos about our solar system and our own planet Earth. Saturn. This planet is the most memorable in our solar system. Everybody knows that Saturn is that planet that has rings around it. That's why I call it the Lord of the Rings. However, this planet bears more secrets and surprises that we expected. Breathtaking and complex ring system, it has numerous moons, more than we thought before, and some of them might even support life. This sixth planet from the Sun and the second largest planet in our solar system, people call the jewel of the solar system, and there's a good reason for that. Let's in this video talk about why this planet is so interesting in the light of the new research and the Cassini probe exploration, and based on the new images, data, and observation. We'll talk about something that surprised us about Saturn, something you didn't know before, and why it's made this planet very interesting for us. What is interesting about Saturn, that this planet is, as I say, sixth one. It's the next second big planet after the Jupiter, and it's located between Jupiter and Uranus. Saturn, it's the last visible from our Earth's planet without any sophisticated equipment. So people knew about Saturn for some time. Actually, in a simple telescope, you can see the rings. And I bet all of you, when you were teenagers or children, you observed Saturn in a telescope and you were astonished. This is the first planet which I recommend for everybody to observe with your children. When you see those rings, it's amazing. However, you know that Galileo Galilei saw these rings and he was astonished, but other day when he was observing it, he didn't see them. Knowing now the fact that depends on the tilt of the planet, these rings could be very pronounced, or we're gonna look in the profile of them and we not see them. But already back in the day, we knew there's a rings around that planet, which is the main characteristic of it. However, we also know that it's the gas giant. As a Jupiter, see my video about the Jupiter, it mostly consists of the gas, helium, hydrogen, however, not only. And because of that, it makes this planet large, so its mass 95 times more than of our Earth, but has very low density. It's the only planet in our solar system, the density of which is smaller than the density of the water. You can imagine, if we have this planet dipped into the huge pond of water, it will float. Often people compare Saturn to the Jupiter. These planets have similar composition, and they have cloud bands as well with the big storms. However, we know that the Jupiter's areas are more severe and more frequent than on a Saturn. Therefore, the Saturn is kind of smaller version of the Jupiter. It is interesting to know that the distance from the Sun in a Saturn almost twice as distance from the Sun in a Jupiter. So you can imagine that it's very far. And it rotates around the Sun in almost 30 years, Earth's 30 years. It makes one spin around the Sun, just because it's so far from it. Therefore, you can imagine by the time you're in your 30s, it will be just a 1 year on the Saturn. However, this planet is tilted, similar as the Earth, and it have pronounced seasons, but the seasons quite prolonged. It takes about 7 years to have one season there. Luckily, it's more frequent for us, so we don't get bored. Saturn is a little bit squeezed from the poles, so its equator radius is much more than from pole to pole. It's about 10%, and it's one of the biggest in our solar system, and it's because of these gaseous substances. How long is the day on Saturn? We don't know for sure. The haze and clouds keep us from being able to directly view the surface of the planet. And the clouds generally rotates around the planet in high speed. It's hard to understand what is the actual rotation of the planet. However, the probes as Voyage 1 and the Cassini in 2004 recently returned an estimate of 10 hours 45 minutes and 45 seconds for the 1 day. Quite fast, isn't it? So the Saturn is the gas giant, and it's mostly consists of hydrogen. So light, that's why its density is so small. And it has no solid surface, that's why we categorize it as a gas giant. However, it doesn't seem like there's just a gas throughout. We have such high temperatures and pressures within that cause the hydrogen and other elements to behave differently in some kind of form of liquid or plasma. And scientists suggested that Saturn has a rocky core, which is similar to our one on our planet Earth. There is iron, nickel, silicate rocks, and it's estimated to be from 10 to 20 times the size of the Earth's core. Around the core is suggested to be an ice made of ammonia and other elements, and then very pressurized metallic hydrogen. So the hydrogen is actually the gas, but under the high pressure it behaves as the metal. And when we start moving towards the surface, the molecular hydrogen changes from liquid to a gas. Saturn appears to be yellow. Partially it's because the planet have ammonia, different types of ice, ammonia hydrosulfate, and water. We categorize the weather there as a mild weather system. Density, pressure and temperature all increasing as you pass through the atmosphere into the core, resulting in a very hot interior, about 11.7 southern degrees Celsius. We know that the Saturn emits more the energy than it's receiving from the Sun. Apparently it's received about 1% of energy that's coming to our planet from the Sun. And because of this gravitational compression and the high pressures, it's actually emitting some energy, and it could be detected in the ultraviolet images. Scientists suggested it's happening because the interaction between helium and hydrogen in the atmosphere. Because of the core of that planet, we observe the strong magnetic field around it, similar like on our Earth. It's probably because of this metallic hydrogen, it's generates this electric current that's responsible for this magnetic field. It's dipole, north and south poles, respectively, and we even can observe the auroras around the poles of the Saturn. While on the subject of that, let's talk about the clouds of Saturn. It seems like Saturn looks very uniformly, just yellow. However, there are bands of clouds, similar like we see on Jupiter, although they're more organized than there. The composition of Saturn clouds depends on where you are in the atmosphere. The pressure increases and temperature drop as you travel further down through the layers towards the planet core. As we say, the upper layers, it's ammonia ice, followed by water ice clouds, and a layer of ammonium hydrosulfide ice mixed, and then the bottom layer is ammonia mixed in water droplets. Similar like a Jupiter, it's have bands of clouds that are divided into zones and belts. Darker clouds tend to be thinner and lower, while the lighter ones are denser and higher. From the Earth, we cannot observe very clearly those bands. However, the Voyager probe flew by Saturn, and you can see the clear distinctions between these bands on the image the Voyager gave us. Saturn has strong winds and even the lightning storms, similar like we have on our planet. However, the wind on Saturn is very fast. It can reach the speed of 1.8 thousand kilometers per hour. And also very intriguing, we observe some storms that are appearing and disappearing. For example, white dots, similar like we have a red dot on the Jupiter, and it seems like they're reappearing every 30 years or so, every year of the Saturn. However, we can see now and then appearing new spots. And these spots look alike ones on the Earth. However, they don't travel as fast through the system like we have on the Earth, and probably because of this density of the atmosphere. The poles are the most intriguing parts of the Saturn, and before we couldn't observe it from our planet. Intriguing storms that almost like artificial on its poles. The North Polar Vortex has a unique hexagon-shaped cloud pattern with straight sides estimated to be about 13.8 thousand kilometers long, and appears to rotate at the same speed as the interior of the planet. Science is not sure why such particular patterns. However, they did some recent experiments with the differentiated speed of rotating the liquid, and they found that it can form similar shapes. This is the best theory they have so far. South Pole have intriguing but different cloud patterns. There's a big storm there, and it's much warmer than the rest of the planet, and it's believed to be the warmest spot on the Saturn. Let's talk about the Saturn rings. After all, it is the Lord of the Rings in our solar system. Although it's not the only planets that have rings, we know Uranus definitely has rings and small rings on Jupiter. The Saturn rings are the most famous and observable, and they're pronounced. Already in 1981, the Voyager probes revealed around 10,000 separate rings around Saturn. However, the Cassini, only recently finishing its trip to the Saturn system, revealed that the number of the rings could be in the millions. And they're very complex, dynamic, and we have amazing images from that exploration. There's numerous clumps, holes, gaps, other structures, and there's also numerous natural satellites of this planet. Probably the rings are formed when a moon or comet came close to Saturn and was ripped apart by gravitational forces. A long-running theory is that this was early in the solar system history. Traditionally, people think like that. And because the rings gradually spread since then, perhaps forming moons in the process, it explains why there are so many satellites. About 83 known moons in the Saturn. However, Cassini measurements suggested otherwise. Cassini just finished its trip in 2017. It's been in the Saturn system for 13 years. And it gave us a lot of shocking information that we didn't know before about the Saturn. In particular, Saturn rings are lightweight, with a total mass of about 15 billion kilograms, about 0.02% of the Earth's moon. It's most astonishing that the rings are almost pure ice, despite a gentle rain of dust falling into them. And we have to imply that they're relatively young, probably forming just about from 10 to 100 million years ago. This is very young for our solar system. And they could be very lucky to observe them right now because they could be just temporarily. Or maybe rings go through the cycles. Moon collide, forming new rings that coalesce into the moons, which eventually collide again. Interesting that already by 1800 we knew that the rings were not the moons, not a single disks, but many rings comprising tiny particles. Traditionally, we classify rings, and it's divided into rings, arcs, divisions, and gaps. The first 7 rings we discovered were designated to the letters of the alphabet, A through G, so the outermost were D, C, B, A, F, G, and E. 3 other named rings have been discovered since G, and they were named after the moons orbiting with them. Beyond the main rings, there at the distance of 12 million kilometers from the planet is the sparse Phoebe ring. It's tilted at the angle of 27 degrees to the other rings, and it orbits in retrograde fashion. Scientists suggested that some of the moons of Saturn, such as like Pandora, Prometheus, act as a shepherd moons, so they confine the rings and prevent them from spreading. And the jewels of this planet is the moons. We know 83 moons, 53 of which have formal names. Those are hundreds of little moonlets, about half kilometer in diameter, and they're not considered to be true moons, they are within the rings. Titan, the largest moon, comprises more than 90% of the mass in orbit around Saturn, including the rings. Many other moons are small, and 34 are less than 10 kilometers in diameter. The Titan is the only satellite in the solar system which actually bigger than the Mercury, with a major atmosphere. It has complex organic chemistry, and it's the only satellite with hydrocarbon lakes. Therefore, the Saturn's moons are very interesting for us. Explore the oceans and potential the life. Now we are interested in the Saturn more for its moons rather than the planet itself. For example, Immerse is the smallest known rounded body in the solar system. It's 396 kilometers in diameter satellite of the Saturn. On one side there's a huge crater with the walls 5 kilometers high, and it's make it look like the star of Star Wars. We know they've been damaged by this impact. This impact almost destroyed this little moon. However, recent data hints that could be even the ocean on this little moon. And of course, we have to talk about Enceladus, the Saturn icy moon. Before the Cassini recent exploration, we didn't know much about it. We knew about Titan and rings, but we didn't know that there it potentially has the microbial life on it. Therefore, in the past, scientists didn't plan to come back to Saturn and explore it in more detail. It wasn't the priority to spend so much money to explore this planet. However, now the new research from Cassini sparked interest in searching for the life on the oceans of the moons of this beautiful planet. Therefore, maybe in the next decade there'll be another probe sent there to extend the research and focusing on those satellites. That's as much as I would say for this video. It's mostly the general information about the Saturn and some shocking discoveries in the recent Cassini exploration. However, there's so much to talk about. There's a lot of information about the rings, how they behave, where the material come from and why, and also interesting information about the satellites of this planet. So stay with me, subscribe, and we will explore the Saturn little moons in the future videos. Уран. Уран – это газовый или ледяной гигант, планета нашей Солнечной системы, расположенная между Сатурном и планетой Нептун. Эта планета является одной из самых загадочных и необычных планет нашей Солнечной системы и отличается своими особенностями. Об этом поговорим в этом видео. Если вы не являетесь астрономом, вероятно, вы немного знаете об этой планете. Мы знаем, что она очень далеко, это ледяной гигант, и она очень красивого цвета. Что же на самом деле мы знаем об этой планете? Почему на этой планете такие определенные условия? Почему она является уникальной? Давайте поговорим об этом. Первый интересный факт об этой планете – это то, что это первая планета, которая была обнаружена с использованием телескопа. До этого Уран наблюдали много раз невооруженным глазом, и нам он представляется, может быть, как далекая звезда или комета. Но первое наблюдение телескопом, предполагающим, что эта планета, было сделано в 1781 году. Ученым Уильям Хершелем, который, пронаблюдав Уран, предположил, что это комета, описал ее, и потом, после дискуссии с другими учеными, выяснилось, что это на самом деле планета, так как она ведет себя на звездном небе, как другие планеты. И в то время возникло это необычное имя этой планеты – Уран. Уран – это единственная планета, которая названа в честь греческого бога. Другие планеты названы в честь римских богов. Но изначально эту планету хотели назвать Нептун, как бы продолжая последовательность римских богов. Также кто-то предполагал назвать эту планету именем Хершеля, но в итоге после долгих дискуссий решили дать имя Уран. Но несмотря на то, что эта планета настолько уникальна, необычна, казалось бы, мы должны ее изучать очень подробно, на сегодняшний день мы мало знаем об этой планете, меньше, чем о других, И только однажды аппарат Voyager 2 пролетел недалеко от этой планеты и доставил нам кое-какую информацию о ней. В 1986 году Voyager 2, пролетая мимо, доставил нам несколько снимков спутников и также самой планеты. На сегодня мы не очень много знаем об этой планете. За последние десятилетия телескопы продвинулись, и раньше мы думали, что эта планета достаточно скучная, холодная, там ничего не происходит. Сейчас мы открываем много интересного, изучая эту планету в современные телескопы, и мы сейчас обсудим эти необычные свойства. Что же все-таки мы знаем об этой планете? Уран является одной из планет газовых гигантов, или мы называем его ледяным гигантом. Как и Нептун, Уран состоит в основном из газов и льда. Вы подумаете, что эти планеты полностью состоят из газов насквозь, но на самом деле ученые предполагают, что, например, в середине Урана находится ядро с силикатным составом. Однако на этой планете не наблюдается никакой поверхности, как, например, у нас. То есть вы не сможете стоять ни на какой поверхности там и наблюдать через атмосферу звездное небо. На самом деле в таких планетах очень толстая насыщенная атмосфера газов медленно переходит в более сжиженные газы и льды, и в итоге до середины планеты к ядру. Атмосфера этой планеты в основном состоит из водорода и гелия. Это третья по размерам по радиусу планета в нашей Солнечной системе и четвертая по своей массе. И Уран находится на расстоянии около 19 астрономических единиц от нашего Солнца. Это значит, что он 19 раз дальше от нашего Солнца, чем наша планета Земля. Астрономическая единица – это расстояние от Земли до Солнца. Таким образом, вы можете себе представить, что он движется вокруг Солнца, что Уран движется вокруг Солнца очень долго, и там очень холодно. И так как Уран и 4 других планеты Юпитер, Сатурн и Нептун все являются газовыми гигантами, Уран является наиболее маленьким. Буду предполагать, что Нептун наиболее сходный к Урану. Но, несмотря на это, Уран в 40 раз более массивный, чем наша планета, и его диаметр в 4 раза больше. Но из-за того, что масса такая небольшая для размера Урана, то гравитация на этой планете приблизительно такая же, чуть меньше, чем на нашей планете Земля. И получается, что если бы вы даже смогли где-то находиться на поверхности этой планеты, то вам было бы там достаточно комфортно в смысле гравитации. Одно из необычных свойств этой планеты то, что она самая холодная в нашей Солнечной системе. Вы подумаете, подождите, но Нептун же еще дальше, чем Уран. Там должно быть холодней. Ну, нет, получается, что Уран обладает определенными свойствами. Может быть, это движение вокруг Солнца этой планеты определенное, может быть, какая-то история столкновения с телом во время его формирования. Привело к тому, что сейчас на Уране самые холодные температуры в нашей Солнечной системе. Так, средняя температура на Уране может достигать минус 200 градусов по Цельсию, а максимально холодные места ниже нуля. А в некоторых местах температуры могут достигать ниже 224 градусов, ниже нуля. Одно из объяснений, почему так холодно на этой планете, это то, что тепло из середины планеты, из его ядра не достигает поверхности из-за определенных физических свойств этой планеты. А некоторые даже предполагают, что из-за того, что как по-особенному эта планета вращается вокруг Солнца. И это приводит нас к следующему уникальному свойству этой планеты – это вращение ее вокруг Солнца. Так Уран имеет необычный угол наклона и вращения. В основном все планеты нашей Солнечной системы находятся в одной плоскости и вращаются более-менее в одинаковом угле наклона к нашему Солнцу. Однако Уран находится как бы лежащим на боку. То есть он вращается так, как будто бы он катится по направлению к Солнцу и потом катится от него в другую сторону с полюсами, направленными напрямую, почти что к Солнцу. Если это тяжело представить, посмотрите на картинки. Угол наклона Урана около 97,7 градусов, когда все другие планеты находятся таким углом, что экватор всегда находится под лучами Солнца. Для Урана Экватор будет находиться там, где у нас, например, полюса, и получать меньшее количество тепла. В результате половины года один полюс Урана находится всегда под радиацией солнечных лучей, и потом полгода как бы отвернут от Солнца и находится в тени. Вы можете себе представить, как это будет влиять на климат на этой планете. Почему же Уран так наклонен? Одно из логических объяснений, которое просится, это то, что Уран когда-то столкнулся с большим телом или планетой, минимум размера нашей Земли, который как бы столкнул Уран с его основной оси, и он теперь вращается вот так. Ученые предполагают, что это должно было возникнуть в начале формирования, в первый миллиард лет формирования планет и Урана. Таким образом, может также объясниться наличие спутников вокруг этой планеты, которые тоже вращаются так же, как и планета. Это обломки от вот этого вот столкновения. Необычный наклон этой планеты влияет на все. Также и на магнитосферу этой планеты. Кольца, которые тоже наблюдаются, Урана, также находятся в соответствии с этим углом наклона. Мы насчитываем около 13 колец и 27 зарегистрированных, может быть даже больше, необычных спутников, которые вращаются вокруг этой планеты. По внутреннему составу эта планета необычна. Это газовый гигант, или даже мы его называем ледяной гигант. Сам состоит из газа и льда. Как мы уже сказали, в центре находится каменное ядро, ледяная оболочка вокруг него и снаружи водородная гелиевая атмосфера. Ядро достаточно маленькое и составляет 20% от радиуса всей планеты. И вот эта мантия, которая вокруг ядра ледяная, она составляет большую часть этой планеты, около 60% радиуса. Давление достаточно большое в этой ледяной оболочке, она не является, по нашим представлениям, только льдом. Это на самом деле смесь горячей и плотной жидкости, воды, аммиака и метана. Часто эту жидкость называют океаном водного аммиака, и она обладает высокой электропроводностью. По составу Уран и Нептун отличаются от Юпитера и Сатурна из-за того, что там находятся льды, и они преобладают над газами. Поэтому мы называем и Уран, и Нептун ледяными гигантами.